Welcome to the deep dive. Today, we're jumping into something that's a really big deal in AI right now, AI agents.
Yeah, these aren't just your standard AI models anymore. We're talking systems that can, perceive things, reason about them, and then actually act on their own.
Exactly.
Yeah.
And they're getting seriously sophisticated, but building them well, that takes structure. That's where these design patterns come in, right? Sort of the basic building blocks.
Spot on. Think of them like blueprints.
Mhm.
And our goal today is really to give you the core concepts behind the most important ones. We've sifted through a bunch of material to pull out the key ideas.
Good stuff. So we picked out 6 main patterns that seem to be, well, everywhere when you look at how these next-gen agents are being built.
Mm-hmm.
We've got React, then there's CodeAct, modern tool use,
Self-reflection or refinement.
right, multi-agent workflows, and the last one is agentic argy.
Okay, quite a list. And the plan is to unpack each one, get the gist of how it works, why it's important, maybe see some examples, make it clear, and hopefully pretty engaging.
Sounds good. All right, so where should we kick things off? Maybe with like the real foundational one, React.
Yeah, React. It's a reason plus act, right?
Yeah,
Super
okay.
fundamental pattern, really.
Reason and act. Makes sense.
Exactly. And the core idea is this constant back and forth. The agent thinks that's the thought, and then it does something in the world, the action.
Right, so it's not just like think once, do once. It's a loop. Why is that loop so important?
Well, that looping is super important, especially for, agents using LLMs, because they know a lot, but not everything.
Right, they have gaps, like
Yeah.
blind spots in their knowledge.
Precisely. So by acting, by reaching out to the external world, using tools, they can grab the info they're missing. It helps ground them, stops them making stuff up, hallucinations.
Ah, grounding. Got it.
Mhm.
So how does that loop actually like work step by step? What's the flow?
Okay, so it starts with the query, right? What you ask the agent to do.
Uh-huh.
Then it goes into thought mode. It
Yeah.
thinks, okay, what do I need to figure out here? Maybe break this down. Based on that thought, it decides on an action. Like, I need to use the weather tool, or I should search for this.
Takes the action.
Takes the action, gets a result. That's the observation.
And that observation feeds back in.
Right back into the next thought. Okay, I got this info, now what? Do I need more? Am I done? And this cycle thought, action, observation just repeats. There's even a technique called React prompting to help guide the LLM to work this way.
Okay, so it's constantly thinking, doing, seeing, thinking again, adjusting as it goes.
That's the key, the synergy. Thinking guides the action's results refine the thinking, it lets the agent adapt dynamically.
Can we walk through an example, make it a bit more concrete?
Sure. Let's say you ask, what was the weather in London yesterday and who won the big football match there?
Okay, 2 different things needed.
Exactly. So the React agent thinks, okay, need weather, need sports result. First action. Maybe call a weather API for London yesterday. Observation. Gets the weather data.
Okay, part 1 done.
Then it thinks, still need the football result. Second action. Use a sports news search tool. Observation. Finds the match winner.
Right.
Finally, it puts both pieces together and gives you the full answer.
Yeah, that makes it really clear how it breaks down the problem and uses tools iteratively.
Yeah.
I think the sources also mention things like a digital journalist using search or an agent using a calculator and Wikipedia for stats.
Exactly. Those are great examples. And this isn't just academic. React is like everywhere. Most agent products you see probably use some form of it.
And frameworks like LangChain and Llama Index make it easier to build these.
Definitely. They provide the building blocks, which is why it's so widespread. It's really a cornerstone.
Okay, cornerstone established. React, reason, act, observe, repeat using tools.
Okay.
Got it. Now, number 2 on our list was CodeAct. The name kind of gives it away. Involves code.
Spot on. CodeAct is a pretty significant step up. Instead of just using predefined tools.
Like APIs.
Yeah, like APIs or simple functions, CodeAct agents can actually generate and then execute code, usually Python, to handle more complex stuff.
Whoa, okay. So it's writing its own little programs on the fly. How's that different from React, fundamentally?
Well, with React, you're limited by the tools you give it, right?
Yeah, if there's no tool for X, it can't do X.
Exactly. CodeAct gets around that. It can write custom Python code to do pretty much anything Python can do, complex math, data crunching, talking to systems in specific ways. It's much more flexible. It basically turns all interactions into writing and running code.
That sounds incredibly powerful. The workflow must be a bit different then.
A little. It starts similarly. Query comes in, agent does some thought, But then if it realizes, hey, I need to do some serious calculation here, or maybe manipulate data in a tricky way,
Something a standard tool can't handle.
right, it then generates the Python code needed for that specific task.
And then just runs it. Is that safe?
Good point. It runs it, but crucially, usually inside a sandbox, a secure, isolated environment.
Okay, phew. That makes sense. So it can't mess anything up.
Exactly. Security is paramount. But within that sandbox, it can leverage all of Python's libraries, NumPy, Pandas, Matplotlib, whatever it needs. It unlocks complex problem-solving, data analysis simulations.
Can you give an example of something a CodeAct agent might tackle?
Okay, imagine you ask it to simulate a projectile's path, but including air resistance, and then plot the results.
Right. That's definitely not a simple API call. Needs physics, needs visualization.
Precisely. So the agent would reason, I need to solve these equations, then make a graph. It would then generate Python code, maybe using NumPy for the math and Matplotlib for the plot. It runs that code in the sandbox.
Gets the trajectory data and the graph.
And presents that to you. A much deeper capability than just calling preset tools.
Yeah, that's a big leap. The source mentioned simpler things too, like adding numbers and checking primes, and its role in AI helping write software.
Yep. All relevant. It can handle basic coding tasks or be part of much larger AI-driven development workflows. Some researchers, Marius and colleagues, really push this architecture.
And there are tools for it, like LangGraph has a CodeAct library.
It does, and you see it in action in platforms like Manus.im and OpenHands that used to be OpenDevin. They really lean into this code generation capability for more autonomous agents.
Very cool. Okay, so React uses tools, CodeAct makes tools, or code anyway. What's next?
Modern tool use. How is this different from, say, React using tools? What makes it modern?
Good question. Modern tool use is really about integrating those pre-existing tools, APIs, functions, databases, but in a very structured and efficient way. The modern bit often comes from using an orchestration layer.
Orchestration layer, like a conductor for the tools.
Yeah, that's a decent analogy. Sometimes called an MCP server model or a managed control plane or something similar. It acts like a central hub that manages how the agent talks to all the different tools. It might handle context, state, that kind of thing too. Okay, and how does that relate to things like function calling in new LLMs?
It ties in very closely. Function calling is basically the LLM being able to say, hey, I need to run this specific function with these specific arguments. The orchestration layer makes that process smoother and more robust.
So the agent doesn't talk directly to the tool?
Often no. It talks to the orchestration layer. That layer figures out, okay, the agent wants to book a flight, I need the airline API. It formats the call correctly, sends it, gets the result back, maybe cleans it up, and then hands it back to the agent in a nice, consistent format.
So the orchestration layer handles all the messy details of each specific API.
Exactly. All the authentication, the different data formats, the error handling, it abstracts that away from the agent.
What's the main advantage there? It seems like more layers.
The key idea is structure and robustness. It's often more reliable and secure than, say, dynamic code generation for every interaction. You're using known, tested functions via a managed process.
Can you give an example? Maybe the travel agent one again?
Sure. With modern tool use, the travel agent wouldn't directly hit the airline API, then the hotel API, then the weather API. It would tell the orchestration layer, I need flight options, hotel options for these dates, and the weather forecast.
And the layer handles talking to each specific service.
Right. It knows which API does what, how to call it, what the response looks like. It gathers all that info and gives the agent a consolidated package to work with to build your itinerary. Much cleaner for the agent.
Yeah, I can see that. Streamlines things. And the sources said this is common too. Databases, knowledge bases.
Oh yeah. Anytime an agent needs reliable access to existing systems or data sources, frameworks like LangChain and Llama Index heavily use function calling, which fits this pattern. Tools like Cursor, the AI code editor, probably use something similar for integrating coding tools.
Okay, makes sense. A structured way to use existing tools via a middle layer. Got it. Number 4 takes us in a different direction. Self-reflection refinement. This sounds internal.
It is. This pattern is all about the agent improving its own work before showing it to you. It's like adding a quality control step or a self-editing phase.
So the agent generates something then, critiques itself. How does that work?
Basically, yeah. It assesses its own output against certain criteria. It might ask itself, is this clear? Is it accurate? Did I actually answer the question fully?
How does it do the critiquing? Does it need another AI?
It can work a few ways. Sometimes it's the same LLM, just reprompted to act as a critic. Okay, now review this text you just wrote for clarity. Or it could be a separate specialized model trained for evaluation. Or even in some complex setups, another agent entirely whose job is just critiquing.
And what sort of criteria does this critic use?
Things like clarity, obviously, factual accuracy, maybe checking against its sources,
Hmm.
coherence, does it flow logically, completeness, did it miss anything, even things like safety, bias, tone.
Okay, and once it gets the critique.
It refines the output. It revises based on the feedback. Okay, this part wasn't clear, let me rewrite it. Or, I need to add a source for this claim. It can even loop through critique and refinement multiple times until the quality hits a certain bar.
Wow. So it's like having an internal editor constantly polishing the output. What's the big win here?
The main thing is much higher quality, more accurate, more coherent, safer, just, better output. It mimics how humans review their own work, catching mistakes and improving things before hitting send.
Can you give an example?
Sure, imagine an agent writes a draft report. It then self-critiques. Is the executive summary clear? Are all the data points cited correctly? Did I address all parts of the prompt? Is the tone neutral? Based on the no answers, it goes back and fixes those specific parts.
And this applies to code generation too.
Oh, absolutely. An agent could write code, then critique it for bugs, style issues, security flaws, and then try to fix them itself. Really powerful for improving reliability.
Seems super useful. Sources mentioned OpenAI uses this,
Hmm.
and open source tools like OpenDevin again, and something called reflection.
Yeah, it's definitely a technique being explored and used. OpenAI mentioned something like it for improving model outputs. OpenDevin, focusing on software development, needs reliable code. And reflection is a specific research approach focusing on this kind of self-reflection loop. It all points towards making agents more dependable.
Okay, makes total sense. Build in quality control. Right, pattern 5, multi-agent workflow. Sounds like teamwork for AIs.
That's exactly it. This pattern tackles complexity by basically assembling a team of specialized AI agents who collaborate. Think division of labor.
So not just one super agent trying to do everything.
Right. You break the problem down. Maybe you have one agent that's great at research, another that's good at writing, another skilled in data analysis. Each focuses on what it does best.
How does that work in practice? Is there a manager?
Usually, yeah. There's often an orchestrator agent or like a project manager agent. It gets the main request, figures out the different steps or components needed.
Decomposes the task.
Exactly. Decomposes it into subtasks. Then it assigns those subtasks to the specialist agents based on their skills or the tools they have.
And the specialist agents just go off and do their bit.
Pretty much,
Yeah.
they execute their assigned task. And interestingly, a specialist agent might internally use another pattern, like React or modern tool use, to get its specific job done.
Ah, so patterns within patterns.
Can be, yeah. Once a specialist finishes its task, it sends the result back to the orchestrator.
And the orchestrator puts it all together.
Yep. It synthesizes all the pieces from the different specialists into the final output or solution for the user.
Okay, that seems logical for really big, complicated problems where one agent might struggle. Can you give a solid example?
Think about building a new software feature. The main request comes in, the project manager agent breaks it down.
Okay.
It might assign defining requirements to a requirements analyst agent. Designing the architecture goes to an architect agent. The actual coding to a coding agent. Testing to a testing agent. Documentation to a documentation agent.
Like a virtual software team.
Exactly. Each agent does its part, reports back, and the PM agent coordinates and integrates. You also see this in complex research. Maybe one agent finds papers, another analyzes data, another writes sections of the final report.
That makes a ton of sense for scaling up complexity. Sources mentioned Google's Gemini research using this, and frameworks like LangGraph and Crew AI are built for this kind of thing.
Yeah, Gemini involves complex coordination, likely multi-agent. And yes, LangGraph and Crew AI are specifically designed to help developers build and manage these collaborating teams of agents. It's a major approach for tackling really tough challenges.
Okay, very powerful. Right, last one on the list, number 6. Agentic RAG. Now, we know RAG retrieval augmented generation helps ground LLMs with external info. What makes it agentic?
Good question. Agentic RAG takes the core idea of RAG pull in relevant info, use it to generate a better answer, but makes the retrieval part much smarter and more dynamic. It's driven by the agent's reasoning process.
So standard RAG might just grab a chunk of text based on keywords, maybe.
Often, yeah. Or it's a fixed pre-processing step. Retrieve first, then generate. In agentic RAG, the agent thinks about retrieval. It asks itself, Do I need external info right now? If so, what specific information would be most helpful? And how should I go about getting it?
Ah, so it's an active decision-making process within agent's flow.
Exactly. The agent receives the query. It reasons, okay, I need up-to-date facts for this. It then uses its tool search, database query, whatever, to fetch relevant data. But here's the key difference. It doesn't just stuff that raw data into the LLM.
What does it do?
It processes it first. It might summarize the key points, pull out specific figures, filter out noise, basically refine the retrieved information into a much more useful, targeted context for the LLM.
So it's more discerning about what context it uses.
Way more discerning. And it can be iterative. It might do an initial retrieval, realize it needs more detail on a specific point, and then go back and do a more targeted retrieval based on what it learned.
That sounds like it would seriously boost accuracy, especially for factual stuff.
Huge boost. That's the core idea.
Yeah.
Make RGAG dynamic, intelligent, driven by reasoning. You get much better quality, much more accurate, well-grounded answers, especially when facts matter.
Can you give an example of agentic RGA in action?
Okay, let's say you ask about a company's latest quarterly earnings.
Right. Needs recent specific data.
Exactly. The agentic RAG system thinks, need financial data, very recent. It uses a tool to query, say, a financial database or news API for the latest earnings report.
Gets the report.
Gets the report. Now, instead of feeding the whole PDF to the LLM, it processes it. It pulls out key numbers, revenue growth, profit margin, maybe highlights from the CEO's statement.
Extracts the important bits.
Right. It feeds that condensed, relevant information to the LLM as context. The LLM then generates a concise answer based on those key facts, maybe even citing the report.
And if I asked a follow-up about, say, R&D spending from that report,
The agent might realize its initial extraction didn't grab that detail, so it could go back to the retrieved report or even retrieve it again if needed, specifically looking for R&D figures, process that, and then answer your follow-up. Much more intelligent interaction.
yeah, that sounds way more sophisticated than just basic retrieval. Sources suggested Perplexity AI might use this.
It seems likely platforms like Perplexity that excel at giving sourced, factual answers probably use something like agentic Argo intelligent dynamic retrieval and processing, not just keyword searching.
Well, that was quite the tour through these 6 patterns. Really helps clarify how these agents are being built. Could you maybe just quickly recap the main idea of each one again? Just the headline.
Sure, so React, the basic loop of reason and act using tools. CodeAct, generating and running code for complex tasks. Modern tool use, structured, orchestrated use of existing tools.
Right, then self-reflection. Critiquing and improving its own output. Multi-agent workflow.
Yeah.
Specialized agents collaborating as a team.
And finally, agentic RGA, smart dynamic retrieval and processing of information to ground answers.
Perfect. And a really important point you made earlier, these aren't necessarily used in isolation, are they?
Absolutely not. That's key. You often see them combined, like a multi-agent system where each specialist agent uses React inside its own process.
Or an agent using React,
Yeah,
but one of its actions might actually be an agentic RAG process to get information.
exactly. Layering these patterns is how you build really sophisticated, capable AI systems. The possibilities when you combine them are, well, pretty vast.
It really does feel like we're seeing constant steps forward here. The way these patterns are evolving and being adopted, it's leading to agents that are just more capable, more reliable,
Yeah.
more useful, basically.
Totally agree. These design patterns are paving the way for AI to tackle much more complex real-world stuff effectively.
So for you listening, maybe something to mull over. Think about a problem you're working on or just something you're curious about. How could you apply some of these patterns? Maybe React, maybe multi-agent, maybe combining a few to approach that problem.
Yeah.
It's a great way to sort of internalize these ideas.
Good thought exercise.
Definitely. Well, thanks so much for joining us for this deep dive.